Hey everybody, Dr. Nelson here. This is a video about how to graph two variable inequalities. Okay, so there's going to be some notes involved with this lesson, so take some notes on the first few pages, and then you have a chance to try some problems in your own, and then at the end you can see how you did. Alright, so take a look at the first page. We have a linear equation on the left hand side, and then a linear inequality on the right hand side. Okay, and can you tell the difference? Well, the linear equation, okay, all the solutions to the equation are on this line, right? So that point right there is the solution, that point right there is the solution, that point right there is the solution, and all the points in between. Remember, this line goes on forever, right? Well, for the linear inequality, all the points on this particular line are a solution to the inequality, but also all the points in the shaded region as well. Okay? So linear inequalities have a whole lot more solutions, more times than not, than linear equations. Alright? So if you turn the page, let's talk about, again, some of the differences here. Alright? It's important to know the different aspects of graphing inequalities on the coordinate grid. Okay? When graphing inequalities on a coordinate plane, you need to follow the guidelines above. Okay? If the sign is less than or greater than, you will put a dashed line on the coordinate grid because it means that that part of the graph is not included. Please underline the word not. Okay? If the sign is less than or equal to, please underline equal to, or greater than or equal to, you will put a solid line to show that all the points at that part of the graph are included. Okay? So I'm sure you remember when you graphed this linear equations where you'd have open and closed circles. Okay? Well, when you graph linear two variable inequalities, instead of it now being an open or closed circle, it's now going to be a dotted line or a closed line. Okay, and this will all make sense to you in a little bit. Next page. All right, so take a look at this two variable inequality. Okay, it's x plus 3y is less than 0. All right, and notice that we have a dotted line. Okay. That's because it's less than, all right? So the values on this dotted line are not solutions to the inequality, but all the values in the green are solutions, all right? So the question is, in the graph above, is point 0, 0 a solution to the inequality? And how do you know? Well, 0, 0 is the origin, right? And that's right on the dotted line. So the answer should be no, but let's prove it, okay? So let me rewrite the function here. X plus 3y is less than 0. All right. Now let me plug in 0, 0 for the x and y value. So it's going to be 0 plus 3 times 0 is less than 0. So this is going to be 0 plus 0 is less than 0. So the question is 0 less than 0? And the answer is no. So because of that, 0, 0 is not a solution to the inequality. All right? All right, next page. Let's take a look at this one. Okay? Here we have the function 2x minus y is less than 2. All right? And the question is 1, 0 a solution to the inequality? Okay, how do you know? Well, take a look. This time we have a solid line. And the reason why it's a solid line, okay, is... Actually, this should be less than or equal to. Please add that line. The reason why it's a solid line is it's less than or equal to. All right? And the question is 1, 0 a solution to this function? Well, let's plug in the values. So if we have 2 times x minus y is less than or equal to 2, let's plug in 1 for 0. So 2 times 1 is 2 minus... Let's plug in a 0 in for the y. Is less than or equal to 2. So the question is 2 less than or equal to 2? And the answer is yes. Right? That's why 1 and 0 is a solution to the graph. Okay, and that's why it's a solid line, because it's less than or equal to. Alright? Alright, let's go to the next page here. Alright. Now when you graph a two variable inequality, you will graph it just as you would an equation. All right, so see the example below. All right, so if you can, take the function and put it in the slope-intercept form. All right, and then graph it. All right, then you'll need to pay attention to the two additional pieces of information for graphing inequality. So number one, should the line be solid or dashed? Okay, and then two, which way should you shade the inequality? All right, so looking at this graph here, all right, y is greater than x plus 1, okay? And because it's just greater than, that's why it's just a shaded, that's why it's a broken line, not a solid line, all right? If you go to the next page, actually not yet, so now the question is, how do you shade, or what side do you shade, all right, the top or the bottom of the line? Well, here it says y is greater than x plus 1. So what I do is I go to the y-intercept right here, which is at 1, right? And the y values have to be greater than that, right? So for the y values to be greater, I want to go up, right? So because I'm going up from the y-intercept, we're on this side of the line, right? That's why this was all shaded in. All right, if it was y is less than x plus 1, then I'd be going down this way, and I'd be shading this side. All right. So this was just a little introduction to how to graph two variable inequalities. So when you pause the video and try the your turn now problems, and then when you're done, hit play, and you can see how you did. All right, good luck. All right, welcome back. Let's see how you did with these practice problems. Okay. So the first problem, we have a graph, right? And the question is, does the point 0, 0 satisfy the inequality? Why or why not? All right. So here we have a solid line, okay, and we have all the values that are shaded, our solutions. If you notice, 0, 0 is not in the shaded region, right? So the answer is going to be no. All right. 0, 0 is not in the shaded region or section. There it is. Okay. Next question. How do you know which way to shade the inequality? All right. Well, the inequality, here's our y-intercept, right? Okay. And as I go down the y-axis, right, this is the part that's being shaded, right? So because of that, we know that this inequality is going to be y is less than or equal to, okay, whatever the equation is. All right, so let's actually figure out the type of graph this is. So we know the y-intercept is at -1, and we know the slope is going to be up, let's see, 1, 2, 3, and over 1. So we know the slope is going to be 3x, so it's going to be 3x minus 1, all right? Now, so it's going to be y is going to be less than or equal to. So less than or equal to, okay, 3x minus 1. Now this is why it's less than or equal to. Notice that the line is a solid line, right? That means every single point on the line is a solution for the two variable inequality, all right? And now the next question is, why do we shade underneath it? And this is why. Because y is less than or equal to. All right, so remember, you go to the y-intercept, and if it's less than, the y value is decreasing, right? So it's going to be all of this side would be a solution to the inequality. All right, let's go to the last two problems here. And here you had to just graph the two variable inequalities. So here we have y is less than or equal to 3/5 x minus 5. So we're going to have a y-intercept of -5, and then a slope of 3/5. So I'm going to go up 3, 1, 2, 3 over 5, right there. And because it's less than or equal to, we know it's going to be a solid line, like this. All right, and let me get my highlighter here. And now y is less than or equal to. So we go to the y-intercept, and for it to be less than, I need to go underneath that, right? So this section right here will be a solution, or the solutions to the inequality. All right, let's try the next problem. Y is greater than 2x minus 5. Well, this time we have a y-intercept again of -5, and a slope of 2. So I'm going to go up 2 over 1, up 2 over 1, up 2 over 1, and so on. All right. But this time, y is greater than 2x minus 5. So because it's just greater than, we're going to have a broken line that goes through the points, like that. Don't forget the arrows. And now we need to shade in the top part. But this is y, because y is greater than. All right, so here's the y-intercepts right here. Okay, so for y to be greater, we need to go up, right? So it's going to be this side of the graph. So all these values that are in the shaded region are solutions to the two-variable inequality. All right, how'd you do?